Welcome back to the channel. In today's video, we will demonstrate how to evaluate the bearing pressure of the foundation subjected to eccentric loading. Let's consider a strip foundation with the top of the foundation 200 mm below ground level, and located in a soil which has a density of 20 kN per cubic meter. The water table is outside the zone of influence of the foundation, and the proposed foundation is 200 mm deep and 600 mm wide. If the loads from the building are dead load equals 40 kN per meter, and imposed load equals 10 kN per meter, we can calculate the total load to the foundation. Concrete load from foundation assuming density of concrete equals 24 kN per cubic meter. 0.2 meter deep times 0.6 meter wide, multiplied by 24, equals 2.88 kN per meter. Surcharge of soil over foundation, 0.2 meters deep, times 0.6 meter wide, times 20 kN per cubic meter, equals 2.4 kN per meter. As a result, the total load to the bottom of the foundation is 40, plus 10, plus 2.88, plus 2.4. This gives us a value of 55.3 kN per meter. If this load is divided by the width of the footing, 600 mm per meter length, then the bearing pressure becomes 55.3 divided by 0.6 times 1. This results in a value of 92.1 kilonewtons square meter. Assuming the bearing capacity of the soil is 100 kilonewtons per square meter, then 92.1 kilonewtons per square meter is less than 100 kilonewtons per square meter, and the foundation is adequately designed for the subsoil. It is important that foundations are loaded centrally, since an eccentric loading on a foundation can make a difference. The eccentric load can increase the bearing pressure to one side of the foundation, and in some cases the resultant force passing through the foundation may fall outside the middle third of the base. Now, let's consider the same foundation used in the previous example, and re-evaluate the bearing pressure, if the wall is constructed 75 mm to one side of the foundation center. In other words, the wall has an eccentric loading. The total base vertical reaction is 55.3 kilonewtons per square meter and the base width equals 0.6 meter. So, eccentricity of base reaction equals total axial load, dead and imposed load, multiplied by eccentricity 75 mm, divided by total base vertical reaction 55.3 kilonewtons per meter. As a result, the eccentricity of the base reaction is 67.8 mm. Next, calculating the base pressures. The formula for the minimum and maximum bearing pressure are as follows, provided the resultant vertical force acts through the middle third of the foundation. The eccentric load produces a moment. The maximum bearing pressure is provided by direct pressure plus pressure due to bending. Therefore, maximum bearing pressure equals 55.3 divided by 0.6, multiplied by, open bracket, 1 plus 6, times the eccentricity of the base reaction, 0.0678 meters, divided by 0.6, close bracket. This gives us a value of 155 kilonewtons per square meter. And the minimum bearing pressure equals 55.3 divided by 0.6, multiplied by, open bracket, 1 minus 6, times, the eccentricity of the base reaction, 0.0678 meters, divided by 0.6, close bracket. This gives us a value of 29.6 kilonewtons per square meter. The bearing pressure diagram shows that the maximum bearing pressure is greater than the bearing capacity. 155 kilonewtons per square meter is greater than 100 kilonewtons per square meter. Hence, a small shift of the wall on the foundation has resulted in the failure of the foundation. Thanks for watching. We hope you found some useful tips. Check out our website at structuralengineercalcs.com. Please like and subscribe, and let us know what would you like to see next. The human footprint is a masterpiece of engineering and a work of art. Stay safe. Goodbye, and see you soon.